Mr. Beaudoin. I first just want to know, when did you first start working at Heisey?
I started in January 1982. I was hired as a working foreman.
Okay. And what does the company do?
The company makes extrusion blow molds for the plastic bottling industry, and trim tooling and that kind of stuff, all related to the plastic bottling industry.
Okay. And what are the molds made of?
It can be a variety of materials, from stainless steels to aluminums to beryllium copper, different types of aluminum, 70, 75, 60, 61 aluminum are the primary materials.
Okay. What types of tasks were you doing as a foreman?
Well, in the early days, I was working on the floor, assisting mold makers and tool makers in the shop, and handwork was kind of my forte. So I wound up doing quite a bit of that kind of stuff, fine detail work and molds, and that's where I, came in contact with beryllium copper.
Mm-hmm. When did the company first start using beryllium?
It was probably in the early 70s. That's even before I joined the company. So it was, it was being used on a regular basis by 1982. And we used an awful lot more of it then than they do now.
And where was the beryllium coming from?
Well, in the early days it was from Brush-Wellman. That was the only supplier we had in the early days, but to try and get better competitive pricing, we reached out for other copper suppliers, and we found NGK Metals, which is a Japanese-based company, and they sell out of Florence, Kentucky, through distributors here in the U.S.
Now, you all were making these molds. Were you having to heat the metal to make them?
No, not heated per se, but in plates or blocks, cavity details would be cut with different form cutters, ball cutters. It's a machining process where you're taking out material to allow the cavity to develop.
So would you be drilling, welding? What kinds of
Well,
tasks?
welding is a separate operation. That's done in a booth, and we had an exhaust fan that would pull the fumes off, and they also subcontracted a lot of that kind of work out. Now that is like a separate operation. The machining was done on numerically controlled machines. We also used pantograph type duplicators with a manual, and that was manually operated. Okay.
And so were you all working in like a big room? Or?
Yeah, it was one continuous room. It wasn't segmented or departmentalized or anything. So any fumes or coolant or whatever would be all over the place. I mean, it's not like you had to be right over the top of it to inhale fumes off from, say, surface grinding. Now, surface grinding is a wet process, and it's done on a surface grinder. It's kept wet to keep the component cool while you're trying to grind it flat. And it's done with a wheel that's turning at about 12,000 RPM, and the coolant is sprayed off from the part that you're grinding, and there again you're putting a lot of that coolant in the air. Now in the early days we would be grinding aluminum one day, beryllium copper the next day. Did we change the coolant in the tank every day? Absolutely not. It was done only as absolutely needed, and far less than it should have been probably. with what we know about beryllium copper today. 2020 hindsight would have said that stuff needed to be changed on a more regular basis.
So the only place that there was ventilation was when in the welding area, is that right?
Yeah, that was there was a vacuum pulling the fumes off what was being welded, and it was just ventilated out through the wall to the open atmosphere outside the building.
Okay. What types of machine fluids were used?
Well, there were synthetics mostly, and they came in 55-gallon drums, and there'd be formulas for mixing it to a certain consistency by just adding water to it. And one of the reasons that the coolant wasn't changed very often is the water would be what was drawn off from that coolant through the spraying, or with a wheel, it would flush that water, and water would evaporate much quicker. The oil then would be right back in the tank, and water would be added to keep the consistency where it needed to be, because you wanted to cool the surface, not lubricate the surface. There's a difference. That's just kind of one of the fine points of tool and die making. You want to cut the surface, you don't want to lubricate it. So there are percentages that get you to that condition.
You mentioned that they weren't changed very often. About how often do you think?
I would say on average, maybe once a month, and 2020 hindsight would say that if you ground beryllium copper today, you should probably swap that tank out that day and clean it and set it up for what you're going to be doing the next day if you're going to be grinding aluminum. In other words, you don't want to be mixing the two materials into that coolant tank, because you can be grinding aluminum today and you're still flushing beryllium copper out, which can be dangerous from the current standards.
Now you mentioned that in the big open room you would sometimes notice fumes or exhaust and dust. How dusty or was it?
The dust generally was created by the wiping process. Now that's the fine tuning of the cavity surface, and wiping was done dry. There was no coolant or anything to keep the dust down, and it was done because it was just much faster and more convenient, and none of us realized how dangerous the dust was.
Was it such that if you walked into this big open room you would notice the dust, or was
if you knew where to look? In the areas where the guys were actively wiping cavities, you could go over there and wipe it off the bench and pick it up on your fingers very easily. And a lot of times when I would be in the wiping area actively working on stuff, I would be sneezing almost constantly, and my fingers up in here would all but turn green because of the copper, and that wasn't totally unique to me, but other fellows didn't seem to quite have that much of a problem. And as far as wearing gloves or anything like that, they were never offered, and we didn't realize that we should have been wearing them, because your hands now act like a sponge. So you pick up beryllium copper dust or dust of any type, and it's absorbed into your bloodstream through the pores in your skin.
What about a mask or a respirator? Any sort of protection there?
No protection was ever discussed or bought or whatever, other than rubber gloves probably within the last 8 or 10 years. Before that, nothing was brought into the picture. And in the defense of Heisey Industries, I don't think they even realized that respirators and other types of protection should have been looked at. The standards would change, and through OSHA, and word just never got down to our level. And I don't know exactly where that level stopped, but I, as the working foreman in the shop between the 80s and 90s, I never saw a list of standard changes, and I doubt seriously if my boss did, Tad Heisey. He's not a bad guy. He's probably as much a victim in this whole process as I am, because I don't think he would have intentionally hurt anybody.
And did any of the workers, you as foreman, have any idea that you were being exposed to something that could harm you?
On occasion, somebody would say something, but the standard answer was the only thing we have to worry about is the welding process if it's needed. Everything else, we're okay. We had brought the sniffer badges in that guys would wear on their uniforms or on their aprons or whatever, and they always came back clean. That we were in the safe area. We hadn't gone and exposed somebody to something that would hurt them. According to the sniffer badges, I've since found that the sniffer badges aren't really the best way to check for airborne particulate matter, because air isn't actually sucked through them and collected. It's that's just not how the sniffer badges worked.
Right. So, do you know if these procedures that you describe at this one company, was this typical for other companies in this industry?
Yeah, I mean, we had guys come into our shop who had worked in other shops that used beryllium copper, and nobody ever ran up a red flag and said, hey, you got to change what you're doing here. So I would think that we were typical of, beryllium copper use in the extrusion blow mold building business. Now, the advantage to copper, beryllium copper, is that it's a harder material, and it has the thermal conductivity of aluminum, which means you can suck the heat out of molten plastic that's running at 400 and some degrees in pretty short order. There are other materials that work. The stainless steel is 420 stainless, pre-hardened 420 stainless works pretty well, but the thermal conductivity is nowhere near beryllium copper. So a mold with stainless steel pinch plates is going to cool much slower than a mold with beryllium copper pinch plates. Thus, the beryllium copper mold, or the mold with the beryllium copper pinch plates, has an advantage over the stainless steel mold. But Europeans use stainless steel. They don't use beryllium copper. But their molds are much bigger. There's more cavitation. So what they lose in die time getting that plastic to cool, they make up for in numbers of cavities within the mold.
What are these molds used for?
Again, they're used for the plastic bottling industry, pharmaceuticals, detergents, just about anything you see in a grocery store that's in a bottle. That's the plastic bottling industry. And I could walk you through a grocery store, and I could point out the ones that have beryllium copper pinch plates, or pinch plates in general. Whether they're actually beryllium copper or not, I can't tell you from looking at the bottles, but I can tell you which ones have pinch plates. And they would either be stainless steel or they would be beryllium copper.
Okay. How many, at the peak of the business, how many employees were in your company?
We've run anywhere between 40 to 50 employees. Now that includes some engineering staff, uh, two shifts in the shop. We would run a first and second shift, and we would generally be open roughly 20 hours a day, as it was, usually 10-hour days and more. Myself, I was working around 12 hours a day because I'd have to do the planning for the next day, planning for the second shift, and I also did what's called process planning, and that's writing detailed instruction sheets for the construction of molds. Mm-hmm. So, and that all took time.
Mm-hmm. And how many machines were in the company?
Oh, good question. I would imagine NC machines would be, maybe 8 to a dozen. And then there's manual machines. You got your surface grinders, manual operated milling machines called Bridgeports. So yeah, there's a lot of different types of equipment. But total number of machines, I really don't know.
Mm-hmm. And when did you retire?
Initially, I retired in January of 2013. I retired for a year, and then I got a call from Tad Heisey, the fellow that had taken over my position. He wanted out, so he gave his notice, and Tad called me in to take over the shop and to train a new foreman for him. And so I came back and I worked for, it was around 10 months, breaking in a new person to the job. And they also split up the job a lot too. So, and in that time I went to Vietnam for the company to train people in the Heisey shop in Vietnam. I think I was over there 4 times.
And what made you retire?
I just got tired of working 60 hours a week every week, week in and week out. And there was pressure put on me to do work in the shop, to do more work in the shop. We had lost a fellow who did the thread milling, which milling of the threads in a plastic neck insert is kind of a unique operation. And went to work one morning and he had died the night before. And I was the only other guy in the shop that knew how to cut threads on what's called a Vetco, a threading mill. So they wanted me to do that. And I managed to get one of the NC machines to be able to do the thread milling. But I said that pretty much convinced me that it was my time to retire. I wanted to do other things. I wanted to spend time with